Welcome everyone. Değerli katılımcılar, hoş geldiniz. Before starting, I would like to mention a couple of points. Let me share my screen first. Translation from English to Turkish is available for our participants from Turkey. Please see the interpretation icon on the right bottom corner of the screen, and please select English for those who would like to listen in English. Webinarı Türkçe dinlemek isteyen katılımcılarımızın ekranın sağ alt köşesinde yer alan Interpretation ikonuna tıklamalarını ve açılan pencerede Spanish opsiyonunu seçmelerini rica ediyoruz. Please be informed that your microphones are muted and the camera is off during the webinar. If you have any technical questions, please post your questions through the chat box. During our webinar, you can ask your questions to our panelists to the QA box. Our speakers will try to answer your questions as much as they can. If they cannot answer all of your questions, they will try to answer after the webinar via email. Our webinar is recorded and the link will be placed at Turkish Water Institute's website so that you can access the recording at a later time. During today's webinar, some poll questions will appear on the screen from time to time. We will appreciate if you spare time to answer those questions. Now, once again, we regret that we could not meet you on Monday due to a technical problem, a Zoom problem, actually. Today, I would like to thank you all for joining our webinar titled Lessons Learned from SARS-CoV-2 in Wastewater, Surveillance, Genomics, Early Warning. My name is Esra Erdem. I'm an assistant professor at Marmara University, Environmental Engineering Department, and I will be moderating today's webinar. Today, we have around 300 attendees from different sectors, including academia, industry, government, and non-government organizations from around 20 countries, and I would like to welcome you all. In this webinar, we will be discussing wastewater surveillance studies with distinguished speakers, Dr. Saatçi and Dr. Alparslan Kocamemi from Turkey, Dr. Chandran from US, and Mr. Bagman from South Africa. Since the start of pandemic, a lot of research has been going on, monitoring of SARS-CoV-2 in wastewater, and results of these studies, valuable studies, are shared through several publications and webinars. Even though a systematic framework has not been established yet worldwide, I believe a good amount of information has been collected, mainly on scientific background. In this webinar, we will try to focus on mainly logistics, methods, findings, and most importantly, challenges faced during practical surveillance studies. Moreover, our aim is to share best experiences of our speakers gained through surveillance studies in their home countries. Hence, to provide guidance to attendees, especially who have just started the surveillance studies in their area. Also, we will discuss sustainability of COVID-19 surveillance studies through wastewater all over the world. I feel you are eager to listen to our speakers as soon as possible, so I would like to give the floor to them to share their views on this striking event. Our first speaker is Dr. Saatçi, a special guest from Turkey. Dr. Saatçi is the president of Turkish Water Institute. He is a member of the governing board of World Water Council. Currently, he is coordinating the nationwide SARS-CoV-2 surveillance study in Turkey, which I believe is one of the first and leading studies in the world. Dr. Saatçi will give an overview of importance of surveillance studies in wastewater and will acknowledge the current situation throughout the world. Dr. Saatçi, the floor is yours.
Thank you. Dear guests, dear colleagues, welcome to our webinar. I thank you for sparing your valuable time to join us for the second time. And we could not meet the first time due to the reasons we all know. As the name of the webinar indicates, we would like to share lessons we have learned about the surveillance of SARS-CoV-2 in wastewater. We think sharing information is essential to overcome this terrible pandemic which has touched every aspect of our lives. As the webinar proceeds, we will see that there are many unanswered questions we are facing. We have to share what we know, as well as we will try to share what we do not know. And we will try to ask the right questions. As they say, asking the right questions is solving half of the problem. This is one of the reasons for this webinar, to ask questions and to gain experience. This topic is mainly a combination of engineering and epidemiology. So it's a topic in between and demands the cooperation of many experts from different fields. So what I will do is I will briefly mention some of the challenges we are facing. One of the questions we will ask in this webinar is, can surveillance of SARS-CoV-2 in wastewater, can it be used as an early warning system? Well, I think it can be used, and I think it can be a very cost-effective method, especially when we compare it with the clinical testing. But we have to use the right methods and sampling and analysis. Some of the difficulties we have been facing are logistics of sampling, transportation from wide range of areas, which is the most costly part, and finding a biosafety level lab, number two or number three, is not very easy. The other issue we face is the lack of data. We need more research to correlate SARS-CoV-2 titer measurements that we are making to the observed cases. So far, the number of COVID-19 cases cannot be significantly correlated to the concentrations we are measuring in wastewater. We need more cooperation here. And what we are doing is actually, we are measuring the trends. Trends they are good. They can predict the surge and decline of the cases, but we don't know the number of cases. Maybe 1 week or 2 weeks earlier, we can tell something about the trends. We also need more information, more research on the virus titers shed by the infected people. We still lack enough information in this respect. We also need political will. We keep on measuring and perfecting our methods of sampling and measurements, and we try to standardize our processes. What we are doing is we are making a tool. All the results we get and the methods we perfect, they are not much use if they are not applied to the whole society. So these efforts, they need two legs to walk. One leg is the research we are doing, and the system we are trying to standardize. The other is the political will. We need to reach the policymakers and form political will if these methods that we develop are going to be applied to the whole society. Maybe we need specific webinars for the decision makers so that they can learn and apply these tools we are developing to the whole society. I would very little like to talk about a current challenge we are facing. We have been measuring the virus concentrations in the inlet of many treatment plants. For the last month, we are measuring all negative results, although we know that there are cases in the area which is served by the sewer system. So we think one of the reasons for this is the rise in temperatures. When the temperature of the wastewater is now 23, 25 degrees, somehow we cannot measure the virus. So we have to go closer to the source. Maybe we should go towards what we call the locations of interest. Then we can measure it. Lastly, I will try to mention the need for future research. We need to find out the most effective ways and most economic ways of sampling and measurement. We have to standardize our techniques. We need to concentrate the virus. What we do is we take, let's say, 200 milliliters of the sample and we filter it, like 0.45 micron filters. And when we get negative results, sometimes we take 2,000 milliliters, 2 liters of sample. And to filtrate that sample of 2 liters is a very tedious work, and it takes lots of time. So we have to find methods of concentrating this virus. And we think we can do this using magnetic molecularly imprinted nanoparticles, which are called MIPs. So we think this is a promising aspect. And in the future, we will need real-time measurements. And so that we can tell whether it's increasing or decreasing and learn about the dangers much before and in real time. For this purpose, we have to develop biosensors. The last topic that we need research is that we don't know how much of our treatment methods, processes can remove this virus. We don't know how much of it goes in filtration, for example, or in the disinfection systems, like chlorination or ultraviolet radiation. But luckily, we know that this virus is not strong. It's much weaker than rotavirus, hepatitis A, and poliovirus, which we know that we can remove using our disinfection methods and the other unit operation methods. Well, and I again thank you for attending this webinar and listening to me. I hope we'll have a fruitful conversation, and I hope that we'll have no Zoom problems anymore. Thank you.
Thank you, Dr. Saatchi, for your expert opinion and valuable insight to the topic. Dear participants, we are following the QA box, so please feel free to submit your questions. Now we have poll questions on the screen, and we will be happy if you answer the questions, please. Thank you for your answers. Our second speaker is Dr. Alparslan Kocamemi from Marmara University Environmental Engineering Department. Dr. Alparslan Kocamemi is the scientific advisor and principal investigator of the nationwide SARS-CoV-2 surveillance study in Turkey. She will talk about the SARS-CoV-2 surveillance study in wastewater and sludges of Turkey. Yes, Dr. Alparslan Kocamemi, the floor is yours.
Okay, thank you, Esra. First, I will share my screen. Okay. Can you see my slides?
Yes, we can.
Okay. Okay. Hello, everyone. Today, during this talk, I will talk about our nationwide SARS-CoV-2 surveillance study in Turkey, which has been initiated by Ministry of Forestry and Agriculture at the end of April under the coordination of Turkish Water Institute. And I am the scientific advisor and principal investigator of this project, and I will try to explain the stages of this project briefly. First of all, I would like to start to talk about the steps of the surveillance study. As I mentioned, we started this study at the end of April with the start of the pandemic in Turkey. And our first aim was to monitor the distribution of cases, COVID-19 cases, but not the cases, certainly SARS-CoV-2 concentration in wastewater in different cities of Turkey. And for this purpose, we first identified a pilot city, which was Istanbul, mega city of Turkey, having 15 million inhabitants. And then we started to collect the samples from the Istanbul wastewater treatment plants. And later, we started to collect the samples from the other cities of Turkey in order to evaluate the distribution of the SARS-CoV-2 virus in wastewater. And this study ended at the end of June. I will talk about the results and the steps of this study. And later, while this project is going on, I faced many questions from different people. They are asking, this virus is active or inactive in the wastewater? Is there any risk of suspicion? Is this virus can be infectious through the wastewater? So in order to answer this question, in the second stage of the project, we performed some activity tests. And through these activity tests, we aim to evaluate whether this virus is active or inactive in different parts of the wastewater treatment plant. And now, starting from July, we started to routine monitoring. What I mean by routine monitoring, for the second wave of COVID-19 in Turkey, We are trying to monitor especially the megacities and the touristic places of Turkey. I will a little bit talk about this. And also, we are ready to send our wastewater and sludge samples for the genomic analysis. I will talk about our aim, and most probably Kartik will talk about in detail about the genomic studies. And also, in parallel to this routine monitoring and genomic analysis, we started to perform some scientific researches about the SARS-CoV-2 in wastewater. And among those researches, the two of them is very important for us: novel virus concentration method and biosensors. And I will talk about those scientific researches very briefly during my talk. At the beginning, I would like to talk about the logistics of the study, because in my opinion, the most important part of the surveillance studies is the logistics. Unfortunately, while we are starting this project, there was no time to consider on the logistics of the study. So we started to study very quickly. As I mentioned, the project owner was the government, Ministry of Agriculture and Forestry, and also the coordination is under the Turkish Water Institute. It is another governmental agency, and Marmara University Environmental Engineer, me from this university, is a scientific advisor. So we first decided to develop which method we will use to measure the SARS-CoV-2 in wastewater, because this was the initial part of the study. And to do this, initially, we tried different methods at Veterinary Control Research Lab of, again, Ministry. We started our studies in Ankara, Etlik Veterinary Lab. And we first tried the UF method, and then we decided to continue with the PEG. I will explain the reasons later. After we decided to use which virus concentration method we will use, we decided which primer we will use for the qPCR, and then we started to collect the samples, starting from Istanbul and then other cities. At that point, other stakeholders were included into the project. Who are they? The local municipalities and also some private contractors, because maybe I have to explain the situation in Turkey, especially in megacities of Turkey. Wastewater treatment plants are operated by some private companies, private contractors. So we performed the sampling together with local municipalities and those private contractors who are operating the treatment plants. And after sampling, certainly the transportation is a very big headache for us, because the cold chain transportation was necessary. I will explain the challenges of this transportation later during my talk. But again, another governmental organization, State Hydraulic Works, organized this transportation from all 81 cities of Turkey. And then the analyses were started in the labs, and then this data, and during this lab analysis, certainly there is another scientific advisor from Health Sciences University, and Marmara University Environmental Engineering and this university work together for the organization of the analysis and data analysis. And we are still working together. This is a simple description of the logistics for nationwide study in Turkey. And while Turkey is one of the first country started the wastewater surveillance study in Turkey, and we have some unique characteristics with respect to the other countries. And while I'm preparing those slides, I considered what are those unique characteristics, and those are the major unique characteristics of us. First of all, this project was fully financially supported by government. But as far as I know, in the other countries in Europe and US, not those projects, those studies are not only supported by government. There are also some organizations, universities, and foundations funding those surveillance studies. In Turkey, this was only funded by government, Turkish Ministry of Agriculture and Forestry. And also in this study, we aim to survey all cities of Turkey. This is also the major difference of Turkish study, because In the other countries, mostly the pilot locations were decided, and the scientists were collected samples from those cities or specific treatment plants. And in Turkey, we collected samples from 81 cities of Turkey, yes. And in this study, we didn't only collect the samples from the influent of wastewater, we collected samples from other parts of the wastewater treatment plant. I think this is also a unique characteristic of the study, because in some studies, scientists are focusing on influent, in the others, influent and effluent, but in this study, we focused on influent, effluent, sludge, primary sludge, waste activated sludge, if there is disinfection, before disinfection, after disinfection. So we collected samples from the many different parts of the wastewater treatment plant. And we performed qPCR. It means we measured the SARS-CoV-2 quantitatively. This is also the unique characteristics. We didn't look at it is positive or negative. We identified the number of SARS-CoV-2 in wastewater. And I think most importantly, it is really unique. We evaluated this virus is active or inactive, in other words, infectious or non-infectious in wastewater. And we performed some activity tests through this surveillance study. And those are the unique characteristics of the nationwide surveillance study in Turkey. As I mentioned, we started with the determination of the virus concentration methodology. I think this is the most limiting part of the surveillance studies. In all over the world, there's still question mark about the correct method. There are different virus concentration methods. In the different parts of the world, the scientists are using different methods. In Turkey, we started with US, but we continued with PEG 8000 adsorption method. I will not talk about the details of the method. You can see the schematic description of the method, but what I would like to mention here, the duration of the test. Please look at the left-hand side of the slide. This test, together with the preliminary preparation for the qPCR, takes place about 20 hours, if everything is fine. If you look at the distribution of the time intervals, the longest part belongs to virus concentration step. And this is, I think, the most limiting step of the surveillance studies. We are still searching a shorter virus concentration, quicker virus concentration method in our surveillance study. And this is a map of Turkey. The red dots shows the cities from where we took the samples. Before talking about sampling, I would like to talk about a little bit the types of treatment plants in Turkey, because it may be different from the Europe and US. In Turkey, we have 3 different types of wastewater treatment plants. The first one is the preliminary treatment. We are calling the treatment plants if they are only including physical treatment, I mean screening and grid chamber. There are also plants including only carbon removal. We are calling them as biological treatment plants, conventional activated sludge plants. And we have also advanced biological wastewater treatment plants, in which there is carbon, nitrogen, and phosphorus removal. In this study, we collected, depending on the city, there are different types of treatment plants, certainly. For example, in mega cities, usually there are advanced biological treatment plants. In other cities, there may be biological or only preliminary. And unfortunately, there are still the cities in Turkey which they do not include any treatment plant. And we collected the samples from manholes for the case of those cities. And as I mentioned, we took the samples from the different locations of the treatment plants, but we collected the samples through all 81 cities. And during sample collection, Dr. Saatchi talked about this during his talk, but I would like to mention once more. We first try to optimize the sample volume because our lab capacities were limited. We worked together with 2 labs, Istanbul and Samsun. At the beginning, Ankara was also in the project. We have to optimize the sample volume, otherwise we could not measure the SARS-CoV-2 through the 81 cities. So We decided to use the 250 milliliter volume in our analysis, which is very low for a virus detection, but we had to do this. And for the treatment plants, including composite samplers, we took the samples as composite sample. For the ones who are not including composite samples, we took the graph sample, but mostly, fortunately, in Turkey, there are composite samplers, 4 degrees composite samplers in most of the treatment plants. For the sludge samples, primary and waste activated sludge samples, we collected the samples as graph samples. While we are collecting the samples, we also gathered some data from the treatment plant operators. We prepared a document which asked some information to the treatment plant operators, because at the just beginning, we understood that the concentration of SARS-CoV-2 is changing depending on the many factors in the treatment plant. We first asked to the treatment operators about the general information of treatment plant, population, flow rate, treatment types, to where the effluent is discharged, to where you are discharging the sludge. And also we ask, is there rain during sampling time? This is really important, because if there is rain, we understood that, especially like countries like Turkey, including combined sewer system, rain is causing the dilution of the sample, and you are not catching the virus. It becomes impossible. So this was a very important question. And also, the hydraulic retention time and sludge age, which is the operational parameter for a typical wastewater treatment plant, are really important for the fate of the virus, because depending on the duration, you can monitor the virus more concentrated in different parts of the treatment plant. I will explain this later. And also we asked the actual flow rate, I mean the flow rate during sampling time. Wastewater temperature was really important. Dr. Sarchi talked about this because unfortunately, for example, now the wastewater temperature in Turkey mostly around 27 degrees Celsius, and we couldn't catch any virus in wastewater for a month because of this high temperature increase in wastewater. And then the transportation time started. This was a really terrible part of the project. Fortunately, local municipalities and the state hydraulic works helped us efficiently, and they just arranged the transportation vehicles with cold chain transport, 4 degrees cold chain transport. And also we use the government veterinary labs, which are biosecurity level 2 or 3. This is really important because you cannot perform any SARS-CoV-2 analysis in a lab other than BSL-2 or BSL-3. This is the reason why there is a restriction for the number of the labs. 2 labs just perform the analysis. And maybe for your information, I can show you the distances on this map. You can imagine what we are talking about. This map shows the farthest distance and the nearest distance to the lab. There are 2 labs, Samsun lab and Istanbul lab. And in the case of Istanbul lab, we are talking about 100 kilometers. In case of the farthest distance, which is the Hakkari, we are talking about 1,000 kilometer distance transportation. And if you consider those 2 extreme conditions, we made a very rough cost analysis. And in Turkey, we can say that including sampling, transportation, lab analysis, for the nearest location, the cost of the analysis is about 70 euro. For the farthest distance, it is about 200 euro. It may give some imagination to you about the cost of this surveillance study, especially certainly it is the case in Turkey. And those are our results. Among the 81 cities that we searched, we catch the virus, especially in 7 cities. And this showed us the virus distribution is located in some cities, not distributed homogeneously through the country. Certainly, as we expected, we successfully catch the virus in Istanbul, because Istanbul is the city in which the 65% of the cases were apparent at the sampling time. But we also catch the virus in other cities like Bursa, Kocaeli, Izmir, Antalya, and Ordu. Among those tests, we catch the maximum concentration, about 10 to the power 6 virus titer per liter in Konya, which is at the mid part of Turkey, and the lowest concentration in the Mediterranean part of Turkey as 10 to the power 3. Maybe you cannot be familiar with this qPCR test results. What this virus titer per liter means, I cannot explain now in detail, but for your understanding, I can tell that those tests were performed in instruments, and those instruments have some lowest detection limit. And in our study, the lowest detection limit was 10 to the power 2 virus titer per liter. If the virus concentration was less than that value, we couldn't catch the virus in our samples, and we reported the results as negative. But if it is greater than 10 to the power 2, then we can report the results, as you can see on this map. And as I mentioned, we started with Istanbul. Istanbul is a mega city having 15 million inhabitants, and we are treating about 5.7 million cubic meter wastewater in a day, which is a huge amount. And we have huge treatment plants having capacities of 400,000 cubic meter per day, 200,000 cubic meter per day. We collected the samples from all those treatment plants, from all locations of treatment plants. We mainly focused on Istanbul. And then we started to collect the samples from the other cities. Very quickly, I would like to talk about the results. What these graphs shows us, I will not talk about the numbers and the details of our results because of the time limitation, but what we observed in Istanbul, we catch the virus in both influent and effluent successfully. But when we compared effluent samples with influent samples, interestingly, we catch the virus more in effluent samples with respect to the influent samples. If you compare the percentages, 48% of the effluent samples we reported virus, but for the influent, it was about 35%. It was really interesting. We are still working on this observation, the reason of this observation, but in our opinion, as a team, this is heavily dependent on the type of treatment plants, sludge age, and hydraulic retention time. For example, in Istanbul, we are mostly using extended aeration type biological treatment systems, which means the sludge age is really long with respect to the conventional activated sludge systems. This might be the reason, but still we are working on these comments. When we look at the sludge, okay, we successfully catch the virus more than influent and effluent samples. It was about 47–50%. First of all, why less in primary sludge? I have to explain this because we are different from the European countries. I have to explain the reason of this. In Turkey, primary sedimentation is not a common unit because we have a CN deficiency, carbon nitrogen deficiency in our wastewater. So we are not mostly applying primary sedimentation in our wastewater treatment plants. So in Istanbul, we have 2 plants including primary sedimentation. So we have to mostly focus on the waste activated sludge. In case of waste activated sludge, we catch more sample, and also the concentration of virus was more with respect to the influent and effluent samples. So we concluded that the virus is concentrating in sludge. This was a really interesting result, and as far as I know, this was the first observation in the world. And we are still collecting samples from the sludge part of wastewater treatment plants, and we are trying to find the answer to this question: why the virus is more in sludge with respect to the wastewater. When we look at the Turkey, overall Turkey, certainly the percentages are less because we couldn't catch the virus in all cities of Turkey, but similar to Istanbul, we catch the virus in both influent and effluent, and also we monitor the more concentration in sludge with respect to the influent and effluent samples. So those are the overall results of Turkey very quickly, and we published those results as preprints in that time during pandemic time. We changed our habits as scientists. We are not sending our findings directly to the scientific journals. We are publishing urgently, quickly, as preprints. And we did the same thing in order to inform the other scientists in all over the world about our results. And then we decided to perform the activity test, as I mentioned at the beginning of my talk. We did this analysis with 32 samples. And those samples are from the different parts of treatment plant, not from the influent, not only from the effluent. Those are the locations of the treatment plant. We chose especially we chose the cities which resulted the highest SARS-CoV-2 concentration in sludge, influent, effluent, more than 10 to the power 4. And in these analyses, we used the Vera cell line human kidney epithelial cell, and those tests were done in BSL3, Biosecurity Level 3 lab in Pendik, Istanbul Veterinary Lab. Fortunately, among those 32 samples, we found 31 samples, this virus is inactive. It means it is non-infectious. But interestingly, one sample resulted activity. This was really interesting result for us because we were not expecting this, because as Dr. Sarchi mentioned, the SARS-CoV-2 is a really big virus, as being an enveloped virus. We couldn't expect any activity in the wastewater. But in one waste activated sludge sample, we observed this as active. It was an interesting result and unexpected result for us. And therefore, we decided to continue these activity tests in order to identify whether this virus can be active or inactive in sludge samples. But overall results show that this virus most probably inactive in wastewater, but certainly we have to be careful about its possible activity. And now we are continuing with the routine sampling, as I mentioned, and as Dr. Sarchi mentioned, we just identified some location of interest, and these location of interest are usually the megacities, especially Istanbul. Every week we are collecting samples from the decided treatment plants in Asian and European side of Istanbul. And also we are collecting samples from the touristic places, because in Turkey there are many touristic places in the Aegean and Mediterranean side of Turkey. And we are planning to send the samples for the NGS analysis. With these analysis, we will try to identify the complete genome of SARS-CoV-2 in wastewater. And also we will try to detect the different variants of SARS-CoV-2 in wastewater, and maybe by using the information shared by other scientists from all over the world in the genomic banks, we can decide from which country this virus came to Turkey. Is there any differences between the cities? The variants are different from city to city in Turkey. We will find answers to those questions at the end of this NGS analysis. And I think the Kartik will talk about this in detail during his talk. And as I mentioned, the most limiting step, which is the virus concentration step of the surveillance study, we are working with other universities, Hacettepe Nanotechnology Department, in order to develop a quicker and cheaper virus concentration method. And this method based on the coating of magnetic nanoparticles with molecular imprinting polymers. In order to show the benefit of this method, I prepared this slide. I will not talk about the details of the method, but please look at the left-hand side again, the duration. If you remember the PEG slide that I showed you, it was the duration, total duration was 20 hours. But if we can develop this method successfully, the virus concentration step will decrease to the 2 hours. Instead of 16 hours, it will be about 2 hours. And the total duration of the test will decrease from 20 hours to 5 hours. And this will be a great benefit for the surveillance study. We are still working on this together with Hacettepe Nanotechnology Institute. And finally, we are trying to be a part of biosensor researchers. I have to say researchers because the biosensors are still under investigation. First of all, for the ones who are not familiar with the biosensors, I can explain very briefly, very simply. Biosensors are the devices which will be mounted to the treatment plants, and they will provide the online measurement of SARS-CoV-2 in treatment plant. Without taking any sample, you will have a chance to measure the SARS-CoV-2 online, like pH, like dissolved oxygen, how we are measuring online in our treatment plants, we will have a chance to measure the SARS-CoV-2 online in treatment plants. It's really good. But unfortunately, in the world, there is no any biosensor specific to the SARS-CoV-2 because for these biosensors, especially the biointerface, bioreceptors specific to SARS-CoV-2, it is still unknown, and the scientists are working on to find the biological receptor specific to the SARS-CoV-2. But we are in these studies as Turkey. We are working together with a Glasgow University, and again, Hacettepe Nanotechnology Institute is inside this project, involved in this project. And also there's a spin-off company in Hong Kong, and we are working together in order to develop a biosensor specific to SARS-CoV-2, but certainly it will not be a solution in the short term. It will be a solution for the long-term monitoring of SARS-CoV-2. And finally, I would like to conclude my talk with the challenges of this surveillance study, because there are many problems that we face during this surveillance study. First of all, without the contribution of the stakeholders, this study will be impossible for us. I would like to thank all those stakeholders here, municipalities, Waterworks Institute, certainly at the beginning, the government, Ministry of Agriculture and Forestry, and even the treatment plant operators, workers, and the drivers who are transporting the samples from treatment plants to the veterinary lab. So this is a really, good study showing the good collaboration between different stakeholders. But certainly there are some challenges. The most important challenge is the surveillance studies are really expensive, because the consumables used in those studies are really expensive, especially for the countries like Turkey. And also the duration of the study is a limiting factor. At the beginning of the study, I was telling that we are trying to develop an early warning system by measuring. It is by lab measurements, it is impossible. We know this now, because the duration of the test and the lab capacities are really limiting factors. So if you would like to perform a surveillance study in your country, first of all, you have to find a lab, BSL2, biosecurity level 2 or biosecurity level 3 lab in your country. Certainly manpower is really important. In our country, the lab virologs in Istanbul, Samsun, and Ankara worked really with long time. I mean, they worked even weekends. So manpower is a really limiting point of this surveillance study. And also, as I mentioned, the availability of the consumables are limiting factor. If there is no consumable, what I mean by consumable, if there is no filter, you cannot perform the SARS-CoV-2 analysis. And in Turkey now, we are waiting the filters from Europe about 10 weeks, 12 weeks. This is a real big, the major limitation of the surveillance study. And also the seasonal conditions are really important. As Dr. Saatchi mentioned, now in Turkey, in August, we couldn't catch any virus in any of our treatment plants, although we know that the virus is there, but the temperature somehow affected this surveillance study negatively. This is also a factor that the scientist has to be careful while they are starting their surveillance studies. I hope the information that I gave you will be helpful for the countries, especially that are planning to start the surveillance study. If you have any question, I will try to answer your questions through QA box. Thank you.
Thank you, Dr. Alparslan Kocamami. It's indeed impressive to hear about such an extensive surveillance study. I believe your experiences are quite helpful for our attendees. Dear participants, I would like to remind you that we are following the QA box, so please feel free to post your questions. And again, we have poll questions on the screen. We will be happy if you answer them. Thank you. Our next speaker is Dr. Chandran from New York Columbia University, Department of Earth and Environmental Engineering. Dr. Chandran primarily works on sustainable wastewater treatment, integrating microbial ecology and molecular biology. Dr. Chandran will bring a new perspective to today's topic. He will discuss the viral diversity in wastewater, especially focusing on genomic characterization of SARS-CoV-2. Yes, Dr. Chandran, the floor is yours.
Okay, hello everyone. I hope you can see my slides. Okay, and the audio is clear. All right. So today I'm going to be, there are a couple of ways to do this. I'm going to narrow the presentation itself on some of our recent results in terms of monitoring SARS-CoV-2. And during the Q&A, which probably will be longer, I can discuss more on what we're finding in terms of viral diversity in not just sewage streams, but also other streams. So I've left that open a little bit, but I'll focus more as it relates to this presentation. I'll focus on SARS-CoV-2 and any link to hospital data, and then we can open up the discussion if that is okay, just given the time that we have. Okay. So let's get started right away. So initially, I'm going to focus this discussion on sewage treatment and not on decentralized systems. We have data on that, and I can share that with you also later on. But basically, as it applies to the presentation, at least today, I'll focus on our work around New York City inside the treatment plants, in the influent streams of treatment plants, and also in the sewer shed that feed into the treatment plant. So we are focusing not just on a single treatment plant, we are focused on a community type approach. And the sampling includes locations inside the plant, outside the plant, in the sewer shed, in the pump stations, and so on and so forth. I'll have some details for you in just a few minutes. We are following, again, two levels of inspection of our samples. One is the more targeted approach, using RT-qPCR, reverse transcriptase quantitative PCR for targeted quantification of DNA sequences, but also DNA viruses. And that's the data. I don't have time to share that with you today, but I can quickly pull up the slides if there is an interest on the part of the participants. That can be done. That's the flexibility of these Zoom type webinars. We can go where the questions take us. Okay, so essentially, in terms of the focused monitoring that we are doing, the RT-qPCR based monitoring that we're doing in this community, this is what we have, and I'll take you through the plant basically, this is just a snapshot of the plant, and then I'll take you through the different locations within the plant, and then we'll go. Let me mention, different plants around the world have different configurations, and these are driven by many things, including, let's say, the carbon to nitrogen to phosphorus ratios, the treatment objectives, and the climate, and so on and so forth. And so in this case, what we have is a plant which is treating domestic sewage, largely domestic sewage. It's a combined system, so there is also some contribution of rainwater as well. And so what we are doing is we are essentially tracking the virus through the treatment system within the plant. Let me show you that first. So we're looking at influent pre and post chlorination. This is a fairly unique aspect to this plant, which I'm not really sure is the case for many plants in the US and outside the US. The influent is actually chlorinated to an extent. There are other reasons for this. So we are looking at the impact of chlorination on what we're finding in terms of the virus concentrations, and then we are looking at the differences, if at all, in terms of the grab and the specific location. We are looking not just at the liquid stream, we're also looking at the primary sludge stream and the mixed liquor in the tanks. And then finally, given that we are aligned with the treatment objectives, we are also looking at what the plant is producing. I must also mention that the y-axis on these graphs is all these are all concentrations, and these are volumetric concentrations. So what I'm reporting are copies of what we are amplifying in terms of RT-qPCR, normalized to volume, milliliters of the raw sample. So not liters, milliliters. This is just the convention that we are following, and we can translate this to any units that we want. But just to highlight this, we are normalizing to a volumetric basis for both the liquid samples and the solids samples, which basically are the primary sludge and the mixed liquor. So let's go into the plant. So let's first look at the impact of chlorination on the detected virus concentrations. Again, I'm plotting both the results of both RT-qPCR assays targeted at N1 and N2. These are among the more commonly used primer sets that target the N protein on the SARS-CoV-2 genome. And so again, on the x-axis is time, and then the y-axis is volumetric concentration. We started ours just to give you some perspective. The region that we are sampling is and was, or was at least, one of the most badly impacted communities in the U.S. at that time in terms of COVID, and so it made sense for us to focus in on this community to take a look at the measured concentrations in the wastewater stream. By the time we started sampling, it's a good thing that the impact of the pandemic was already beginning to ease a little bit, and so we probably missed the real bad portion of it, but perspective. And over the summer, we've been following the concentrations. Over the summer in the Northern Hemisphere, we've been following the virus concentrations, and we are seeing some trends, but we can get to that in a few minutes. The point of this slide is to look at, very qualitatively at the very least, the impact of chlorination, so pre-chlorine, post-chlorine, on the measured concentrations of SARS-CoV-2 copies. And basically, if you just take a step back and take a look at these profiles, essentially. And again, we should not be generalizing the impact of chlorination. It is chlorination as conducted at this plant for a given dose and for a given retention time. There does not seem to be a dramatic impact of chlorination on SARS-CoV-2 concentrations. This is very important from a very practical perspective, because one of the first barriers or interventions that wastewater treatment plant operations has to mitigate any impact is to add disinfectants. Chlorine is by far, one of the most widely followed disinfectants. There is a history of doing this in New York City also, as with previous viral outbreaks here, or potential viral outbreaks here. This is look at the impact of chlorine. And the way chlorination is practiced here, there does not seem to be any substantial impact of chlorination on the virus copies. Nothing on activity, just copies. Just moving through the plant, we also looked at the impact of grab sampling and composite sampling on the RT-qPCR results. And as expected, there is a difference in terms of the trends. We do expect that with grab samples, we are not going to get the temporal, the diurnal variability that we would expect, and that is indeed the case. There seem to be some differences in terms of the measured concentrations. So again, from a very practical perspective, if there are groups trying to or surveil, it might be good to focus in on composite samples rather than on grab samples. And then finally, just within the plant, I'd just like to take you through the plant. There are many more slides. I just cut out a lot of them. So again, we are trying to see what the plant is actually doing in terms of SARS-CoV-2 concentrations, because that is also important. It's good to look at what comes into the plant, but also good to take a look at what is going out in terms of the liquid stream and the solid stream. The focus here is the liquid stream now. So if you look at the pre-chlorine influent grab, post-chlorination, and then the effluent final clarifier composite. So essentially what we are seeing is the plant itself, in terms of the liquid stream, is doing a reasonable job in terms of mitigating the viral loads that come in. But however, based on the lower frequency of detection in the final clarifier effluent composite samples, and also the concentrations that are being detected here. So that's the basis for me saying that the liquid stream has a lower load. But really what needs to be looked at is the fate in the solid stream as well. I think there was, this was already presented by Dr. Sache, that there is evidence that the virus is partitioning quite substantially, and even, let's say, there's activity. So this is all happening for us inside the plant. Active in terms of looking at different pump stations that ultimately contribute to the plant. We're also looking at 2 medical center sites which contribute to the plant, and that's what these are: medical center, and then there is this one here. Again, not to go into too much detail with this data, but again to present a fairly high-level perspective in terms of ease of sampling, in terms of the amount of data that we can get. I think it still makes a lot of sense to sample at points which are associated with wastewater treatment plants, because there's already some supporting infrastructure there in terms of sampling, in terms of the other variables that are being monitored at a wastewater treatment plant in terms of operations and objectives. So it's still a good idea. But if we want to make extensions to human health, especially, it might be good to consider a framework where the impact of dilution, the impact of other streams, other non-bodily streams can be minimized. And so in some cases it is possible, and I trust Jay will focus on this when he talks about non-sewage systems. But if the ultimate objective is to link what a human body is producing in terms of virus titers, and if the objective is to link that to human health, then yes, indeed, it is a good idea to measure this in the frame of wastewater-based surveillance, because there is a link. But in some cases, that link might be diluted. In some cases, that link might be confounded by what else comes into the wastewater streams. Having said that, we are still finding a fairly good, rich data set when we start to look at the influence of different wastewater treatment plants. There are 2 wastewater treatment plants in this community. This is the first plant that I've shown you. This is the second plant. So the frequency of detection, the levels of detection are still very good in the influence streams. But it might also make sense to look at pump stations and other sampling points. And I'm just throwing this out there just to, let's say, stimulate some questions that we might be able to take later on. And again, what I presented right now in this short summary is just focused on SARS-CoV-2. We have quite a bit more data, even outside the US, in communities where we are not looking just at SARS-CoV-2. We are looking at essentially the whole virome, if you will, of both DNA and RNA viruses. Okay, now this is our attempt finally to connect what we are seeing in terms of the SARS-CoV-2 concentration. So again, the symbols are similar. So the bars are the N1 and N2 data, again, concentration copies per ml. But then these discrete blue dots are the new cases in the entire county that we are monitoring in terms of hospital records. This is a very difficult thing to do. There are so many factors that we are trying to do here, trying to predict or trying to correlate with what we are seeing in the wastewater streams with human health data. And some of the factors are as follows. Patients might be entirely non-symptomatic, asymptomatic, and still be shedding virus in their, primarily in the feces. Once the symptoms have gone away, patients might still be shedding in the feces. And there might be symptoms and you can argue the other way around as well. So the presence of virus titers when a patient is not symptomatic, and the retention, the lingering on of the virus titers as the symptoms go away. So just by itself, these two factors, just by themselves, these two factors are enough to totally disrupt any attempts at correlating or predicting health information from wastewater information. Having said that, the third factor also is the case not reported at the time shows up is still exhibiting symptoms or still, let's say, shedding the virus, and the time at which the data is actually reported at the public level for us to access this. So we are accessing the hospital records from public databases, which are open. About mathematically, even if we were to take a look at this data visually, the positive thing is we are seeing a positive correlation. So if you just track the dots again, which are hospital data with the qPCR data, there is a correlation. There is a correlation. Now the weakness is are we able to predict human health data? That is a bit. I'm not really sure that that's possible with the data we have. There are some reports saying that the wastewater data is predictive, but in our case, so far, just based on visual observation, we are not able to infer prediction. Correlation, however, is quite apparent, and that could still be a good thing. There could still be an advantage. Instead of testing many people, some people just don't want to get tested. It's inconvenient for them. Maybe it is still a good idea to monitor what they are producing, what is showing up in the wastewater. But again, this question of predictability is a bit open. And it might just be a function of, it might also be a function of where we are sampling. Again, we are sampling in a large wastewater treatment system in a sewer shed. If it is possible to minimize that gap between shedding and the way we are, and the place where we are looking at at quantifying the virus concentrations, we may still be able to get to prediction. But it's difficult to do with a data set that looks like this. So that's on the research side. I'm also involved in some other activities which are more on the policy side. In North America, at least, there was an effort by the Water Environment Federation to develop a set of guidance, develop guidance and a set of recommendations to improve the safety of workers at sewage treatment plants and wastewater treatment plants. That study is now over, and the report should be coming out soon. That study involved a group of researchers, academics, policymakers, including experts from the CDC, OSHA, and the EPA here. That report should be out soon. We're also involved in some efforts to use this data to help, let's say, or to consider informing reopening of communities as they come out of lockdown here. And there are also some activities that I'm involved in terms of national level monitoring efforts outside, in and outside North America as well. And in that framework, standardization of protocols is quite important. I thought I might just add that just to see if there are any questions. But again, I wanted to just mention what I presented today is a small subset. If there are questions more on any other aspects, I'll be happy to take them as well. And my colleagues, my distinguished colleagues on the panel will be happy to, of course, consider them as well. Thank you very much.
Thank you, Dr. Chandran. So we understand that correlation is possible, but for prediction, we need some more research and some time. Okay, I would like to remind you that we are following the QA box, so please feel free to post your questions. Again, we have poll questions on the screen, and we'll be happy if you answer the questions, please. Our last speaker, Mr. Jay Bhagwan, is an executive manager of the key strategic area of water use and waste management at the South African Water Research Commission. He will talk and share the initiatives and early results on establishing a national COVID-19 wastewater and non-sewer surveillance program in South Africa. The floor is yours, Mr. Bhagwan.
Okay. Okay, good morning, good afternoon to everyone. Can you all see my screen? Come on. I think they say merhaba salam in Turkey, this part of the day. So thank you to the Turkish Water Institute for offering us this opportunity, and all my Turkish colleagues for listening. And a special welcome to Michelle Shah from Trinidad and Tobago. It's very, very far away, who's also joining us today. I'm going to share a little bit, and I'm not going to go too much into the scientific detail because I think my other colleagues have covered it quite well, and there's a little bit of variances and experience, and that's what I'm going to share. But in starting to talk about this environmental surveillance in South Africa, I want to add two caveats that, we started on this initiative and journey with the understanding that we are looking for the RNA. So we didn't go into live viruses, etc. It was looking for the RNA signal with the understanding that it's going to be an approximate method, okay? And we're going to learn by doing stuff, not get engrossed too much into the scientific stuff, but let it be kind of a learning, a cyclical process of doing this surveillance and building the experience and the strengths, with the objective that we wanted to get to a space around developing hotspots, developing trends, creating early warning. And the longer term aim was to get into the prediction and quantification where it was viable and possible. So that's the first caveat I want to share on this. So just to, from the Water Research Commission, we're a state agency, that's mandated to stimulate new innovation and solutions in the water environment. And we took this approach on a three-tier kind of engagement. One is that, it was important from the international dialogue around building the communication platforms around COVID, okay? I think from when the first media release went out globally, it sort of got everyone concerned and unnecessarily concerned because it said the virus was live in our water. So, that started to send a lot of shockwaves. And it wasn't communicated properly that we found non-infectious RNA of the viruses in the environment. So, the comms thing is one leg that we're looking at very seriously. The second part is the wastewater surveillance sampling and techniques in itself. And the third part is the ongoing research and development side of it. And I'm going to be very brief on two of the aspects and focus a lot more on the wastewater surveillance part of it. So, this is our website. You could get to it. We've put in a lot of resources, fact sheets, position papers, state of, science reports, etc., and a lot of our science briefs on progress we've been making, etc. So if you're ever interested in on the communication side, this is a platform we created for everyone to come up to par on understanding this whole area of COVID, surveillance in wastewater and non-sewer environments and what we're trying to achieve. The second part is on the research side. This was opportune because, the surveillance was part of our broader water quality, sanitation and health program. And it sort of, we're using it as a platform to actually get, the national wastewater surveillance for many other things up and going, including emerging pathogens, the chemicals, etc. They're not at that strength as yet. So this is giving us an opportunity to build on this program. And we have initiatives in place that I'm not going to talk about today, but look at the infection risks on plant operators, from COVID-19. We're looking at the fate and consequences of the increase of disinfectants in the environment, both from the hygiene aspects as well as the cleansing of the city and stormwater on rivers, etc. So there's a whole lot of stuff we're doing on the research, and that's more longer term in what we're trying to get to. But the heart of the surveillance program, and we took this approach, a very three-phase pragmatic approach, okay? And that meant that, the first phase was a proof of concept. The second one was piloting it. And the piloting was establishing the mechanisms to move into a national wastewater surveillance program easily. So we are at the proof of concept like many, many other countries. And the proof of concept mainly was to establish the sampling protocols and as well as the methodologies around testing, but also establish the capacity and the cohort required and to determine what's the laboratory capacity, what's the laboratory equipment capacity to take this to scale, if we're deciding to move in that direction, so that we know strategically what aspects to tackle moving forward. But also in the proof of concept, and it was going to be obvious, if you're going to look for the RNA and if you can't find it, then there was a big problem. So we just wanted to make sure that we were consistent in the methodology in identifying the RNA in the various streams that we're going to deal with. So just very quickly, the outputs, that we're envisaging is this interlab proficiency that we want to build, look at data integration and trends in the process, establish this network, for the surveillance program across the country. The outcomes we see is all these heat maps, stronger institutional partnerships to engage this, right through the horizontal and vertical elements from the ground right to national government, and establishing strategic partnerships with many players, within the region and as well as international. So we part of the Global Water Research Coalition, also conducting similar exercises, and we feed our information and strategies and outputs at an international level, and that helps to sharpen our initiatives. And lastly, the objective is to make an impact that hopefully through this process, we can establish this early warning process that would become the model for a national water quality surveillance platform going into the future, that we can add value to the current clinical testing, etc., through these early warnings and heat maps. What's unique of what we're doing is that, we live in a world where we have this challenge of SUED and non-SUED. And if you look at it, 50% of the world is non-SUED, okay? And the surveillance that is focused on the wastewater only looks at 50%. And our concern is that, what are we going to do with the other 50%? So that is one of the unique propositions we're looking at. I don't have results yet on the non-SUED, but I would share what we've been experimenting with sampling, but I've got preliminary results that I just received today that we are starting to find, okay, the RNA signal in the non-SUED environments where we are sampling, both on standing pools of water in communities, as well as the drainage areas that leaves a settlement. Okay, we've started to find the RNA signals. And that is a concern because we looked for the RNA, we haven't looked for a live virus yet there. But that's going to open up a whole lot of Pandora's box and concern in that area. Yeah, and the non-SUED sanitation issue is a 2 billion issue, and you can see that, without any sewers and the drainage running through the catchment, it's going to become a problem in the developing world. And I think Turkey and ourselves have the same, what you would call settlement or spatial problems that many of the developing countries in the world have. Where we started, and one of the advantage we had in South Africa is that we had a flurry of activities of proof of concept. So there's about 10 different universities and etc. all got into the space, in tackling this proof of concept. And there's a platform called SACCESS, which is a South African collaboration COVID-19 surveillance system, with a whole lot of laboratories, a whole lot of partners, and all are using different techniques, etc. The challenge is that we have 900 wastewater treatment plants in the country, okay, and across 296 municipalities. So that's a huge challenge to try to orchestrate a national surveillance program. So, working with the public and the private, as well as the academia, in building this national platform is what we're looking at as a strategy. You know, very upfront, etc. The challenge is, you know, not on the PCR side, it's on the sampling side. That's the challenge, and I think that we will get to. But, you know, like somebody earlier mentioned, is that the concentration method is where the real issue sits at, you know, which is, that is the most time consuming. It's the most sensitive because you're having, if you don't use the right techniques, you're having a lot of degradation happening while you're doing concentration, etc. So getting the concentration technique, you know, to be an optimum and really useful solution, a useful technique is what is required. And you'll see that we've been playing around with various techniques around a tangential separation technique using membranes, which is a very novel thing that has come out by one of the teams, that we can concentrate, you know, and create a permeate that is without a lot of destruction, that is very, very good, okay? And we could do it at half the price and in half the time, okay? It's just that the capital layout for this piece of equipment is an investment you have to make, but then you could do thousands of samples, you know, routinely through the system. You know, through a whole lot of, you know, the GHL modified techniques and a whole lot of, you know, commercial kits and the Centricons and etc. I don't have time to go into all of this pasteurization, etc. But these are all the teams. On our website, we last week had a very useful sampling and methodology workshop, and that has been recorded. So I would recommend, I'm not the expert and I can't claim the expert on those matters, but you can get to view the presentations, you know, that were being made, etc., to get an understanding of those variety of interventions that have been happening. So let me tell you the Water Research Commission's little study around proof of concept, and you know, basically this was a 3-month initiative in the hotspot areas in the country, and that was the 4 hotspot areas of the metropolitan cities: the city of Cape Town, the city of Johannesburg, the city of eThekwini, Durban, and the city of Ekurhuleni. That's the 4 we focused on. And the reason we focused on is that we wanted to use this because this is where the cases were really rising. Okay, so we were guaranteed we were going to find the RNA signal, but the intent was to make sure that our techniques and methodologies were fine-tuned around detection of it. Now, what's unique about this is that if you look at the table, is that we went into the non-SUED and the SUED areas of it. So we had 9 wastewater treatment plants that we were looking at across these cities. There were 5 surface water sources that we are looking at. We took 4 hospital sites just to use it as a control around these things. We looked at 2 package treatment plants because there's lots of package treatment plants that are scattered around. We looked, you know, at 1 wastewater sludge because that was the international sort of paper that came out and said, let's include that. And we also looked at groundwater because we have a lot of on-site sanitation systems and a lot of surface contamination, and we wanted to see if that was happening. So, you know, that has been our, you know, we about the tail end of the study, and I was hoping by today I could have got some preliminary results of some of the other areas, and I don't have that, so my apologies. But we've completed a lot of the wastewater sampling, and I will share, you know, the basic results we're getting on those things. So this is the techniques we've used it. You know, we've gone for the 24-hour composite sample, as well as we've taken, you know, the grab sample, etc. It's a weekly sample. You know, the volumes are 1 to 2 liters, collected, stored at 4 degrees Celsius, you know, couriered you know, by plane, and that's about 2-3 hours transport. We've used, you know, in our own technique, the PEG 8000 technique, as well as skim milk, and I'll share with you why we went this route as well, and then the normal RT-PCR screening for the EN and RD-RP genes, etc. So that's, you know, the background to it. I want to get straight into the challenges because, I mean, I could keep telling you about the science and it resonates, but I think it's important when you start getting to it and it's earlier on we're seeing these things. One is sampling. You know, most of our plants do not have any automatic samplers, okay? So strategically, doing the composite and grab was very important to get down to. And you'd see that our results will show you that the grab samples at the right peak loading times, etc., work equally well than the composite samples, okay? And there's a big cost issue around it, around composite and grab in the process. So, you know, that's one of the challenges that, you know, you need to look at. The logistics of transport of samples is you know, it's an issue of time and distance. You know, Bilge talked about 1,000 kilometers, we're talking about 3,000. So hence we're trying to organize the laboratories, both private and public, right across the country, that we can sweep this in a more logistic and effective way, okay? But, you know, the transport, etc., is very expensive, you know, and at the moment, we're hoping that the study will open up or relax some of the regulations around the labs that can do these testing. At the moment, it's locked into 2 and 3, and we don't have many of those labs, and they are overwhelmed in doing the clinical testing as well. So, you know, that is one of the challenges. The sample volumes, again, you know, is the issue of 1 liter versus 250 mils. And that all comes down to courier cost and logistics. You know, the bigger the amount of sample, the more it's going to cost and the more difficult it is. So we're working, there's some novel technique that is emerging where we can precipitate, you know, we can generate the precipitate on site and just ship that out to the lab for the normal PCR techniques, etc. So there's a patent that has been logged in one of the teams, etc., and hopefully they will share that once they've sorted all that stuff. I talked about the viral concentration process. You know, at the moment, everyone's using ultrafiltration because that's the equipment that is available. But it's not the very best of it. You know, if you want better results, the concentration is important. So, you know, we're looking at what other, you know, effective tools we can bring in there. The next point is sampling kits, and I think Bilge talked about it. You know, the availability and costs are a huge problem at the moment. You know, we don't have a continuous supply of it, and we are competing with the clinical testing environment, and the costs are very high. So we were forced in our exercise to develop a whole lot of local methods, okay, with existing products and equipment. And I think that's the way to go. If you're getting to an approximate understanding and you want to develop, you know, this monitoring system, don't try to perfect it with all the best equipment and all the, you know, high-end kits, etc. Because, you know, you don't want a perfect answer, you want a signal. Okay, and that's the important bit. You want to get to using this when you're getting to the prediction and the quantification step. Okay, so just keep that logic in mind when you're designing the program. You know, there's lots of new equipment and new technologies, and yes, they can make a difference. You know, we have a team that is working with an advanced PCR piece of equipment, and they're getting more better results than anyone else. And the advantages we have is that we have several labs testing the same wastewater sample, you know, between themselves, and we have that interlab comparison that is going on the results. But the equipment issues are a strategic decision around the quality of what we're looking for in terms of the results. Last week we had a whole debate around, you know, whether standardization of methods of, you know, testing is the way to go. But, you know, everyone's method is good. They're all finding a signal because we're at a peak, okay? The question is that when the peak subsides, are these methods going to be sensitive enough to pick up the signal or not, okay? But all these methods are not complete and all have drawbacks, and no one talks about the drawbacks openly, You know, they like to hold on to that empire to say, you know, my methodology is working, etc. And then the issue is, you know, and Bilge talked about is time to do the test versus the costs. I mean, you know, we see things from 5 hours to 20 hours, okay? And that's a strategic decision, and it comes with the number of samples you have to do. And we're seeing anytime, we're seeing a range of costs between the techniques. You know, for the longer term techniques of 50 euros to 150 euros, you know, range, and that excludes the courier cost. Okay, a lot of the money goes into the more advanced kits that you have to get. So straight, I'm not going to share all the details. It's a lot of information, but I'm going to just share with you on one treatment plant, you know, over a span of about 6 weeks, the CT values using both the composite and the grab samples. And this is, you know, three treatment plants and 4 treatment plants in the Gauteng area. And you'd see that, you know, we couldn't get the clinical data, but we know that from the period of June when we started, okay, we were hitting our peak in terms of the clinical cases, okay? And until last week or so, or till the middle of July, we started to see the trend beginning to decrease. And you can see that the CT values for both, you know, the grab and collection and the composite readings were very, very good for each of the same plants. Okay, and it was telling us that, you know, we can get away, you know, when things are at a peak with a grab sample, okay, rather than looking at a composite sample, and maybe consider the composite sample when we're getting down to lower clinical cases in the future as an option if you're not getting any signals with the grab sample. So that's just gives you the CT value, and you'll see that it's sitting between 29 and 33, and that's showing you that a very, very strong signal in all the tests that we've been doing over the weeks. We've done a lot of scientific stuff, etc., and this is the Cape Town samples, and you know, we compared the Quantifas kits versus the Seagen kits, etc. And you'll see that, you know, we could, from the comparisons of the N1 and N3 assays, you know, you could see that the Seagen kit is much more sensitive and better in reading. It gives you a more granular result as compared to the Quantifas, etc. So, you know, we have all these graphs, etc., that we're generating from a scientific side, and I couldn't share all of that today. Like I said, you could have a look at our website and the seminar that we hosted. Some lessons then to take away, and I've touched on it, sampling. You know, for us at the moment, grab sampling is performing better than composite sampling. And it's obvious because we have those spikes at the moment, and that helps. But we're taking it at the right time, speaking to the plant operators when we catch a peak. So that is helping quite a lot. You know, this is an advantage when you're sampling from plants that have no composite sampling available, especially the smaller plants in the more smaller towns and cities. You know, you'll have to make that kind of decision. We looked at recovery methods. Like I said, that in our techniques, we looked at we've introduced a very local technique of using skim milk. You know, we're using the PEG system and the hydrochloride, etc. And we find that all 3 recovery methods work well at the moment. But the recovery is variable and dependent on the sample composition, because some of the samples we got were not very, very good, and we could pick that up. At the moment, it's a locally developed technique that we've been using on other viruses, the skim mill method, and we're writing up this methodologies as a best practice, and hopefully we will share them soon. It's cheaper, it's less time consuming, and you need lower spinning for separating the filtrate and those kind of stuff. So those are you know, some of the advantages. We use two inactivation buffers, the ITM and the ENAT, and as well as the PPS. They all performed quite well through the process. Like I said, we also now, once we got the commercial SIGIN and the Quantifast kits, we've done that, and we've in-house as well as identified the N1 gene, through the process. What we've seen is that the SIGIN kit is more sensitive than the Quantifast for the N1 assays, and it has an advantage to amplify all three targets in one reaction. So that's just to keep. And to say that one of the disadvantages of these things is that the CT value must be then used to approximate a viral load. You cannot get it accurately. Okay, and there is techniques we're using through the poliovirus and the other SARS-CoV algorithms that would give us this approximate until we do the load shedding studies in itself. And what we found is that the N target is detected most frequently than the E and the RDP. So it's something to consider when you're going through this process. Yeah, so some takeaways, many of these methods have potential to be sensitive by either, the bigger the sample volumes at a time, or having a more sensitive detection system, such as the ddPCR, or a better, what you would call the virus concentration methods. Okay. It's also a big benefit that we have is that several labs have been testing the same wastewater samples and using very different methods and finding the signals. So that has given us a lot of assurance that these techniques do work, and we can adopt all of them. Rather than standardizing, we can use all of them and create this early warning system. On the sampling side, the grab sampling, like I said, performs better than the composite sampling. And like I said, in smaller plants, that's the way to go. So just saying, with that, thank you very much for listening to me.
Thank you, Mr. Bagwal. We understand that you have been conducting a very comprehensive study, mainly for comparison study methodology and seaward and non-seaward systems. And I believe you will provide a huge contribution to the scientific community.
Yes, it's unfortunately I couldn't share this now because it's a lot of it's another 4 hours of seminar.
Hopefully,
but hopefully
another webinar we'll share them.
Yeah.
Okay.
Right.
Our final poll question will appear on the screen. Please, we will be pleased if you can answer the question. Well, in the light of we have learned from our speakers today, now we shall discuss some key questions, I guess. Dr. Alparslan Kocameme, I would like to start with you. What do you think on spread of COVID-19 through wastewater?
As I mentioned during my talk, to answer this question, we performed some activity tests, and among the 31 samples we tested, we found this virus is inactive. But unfortunately, in one sample, in one waste-activated slice sample, we found the virus active, and this was an unexpected result for us. We are still continuing our research on this, but as a team in Turkey, we have some suggestions for the risk of spread of virus through wastewater. We have to be careful, first of all. And we are advising to the municipalities, local municipalities, do not use the effluents without any disinfection for irrigation purposes. Indeed, this is the case for, before pandemic as well, and we have some strict regulations in Turkey, and we can never use any treated wastewater for irrigation without disinfection, because there are the viruses other than SARS-CoV-2 in wastewater as well. But for this time, under the pandemic condition, it is really important. Do not use the wastewater for irrigation, treated wastewater for irrigation without disinfection. And even if you do not have any disinfection facility in your treatment plant, we are advising to the treatment plant operators use minor amounts of chlorine or chlorine dioxide for disinfection. Okay, this is a good approach for this time, for pandemic duration. And for the sludge, do not use the sludge for land application because there are some places in Turkey, especially in the eastern part of Turkey, they are applying the sludge for the land application. Even we do not accept the activity of the virus in sludge after sludge treatment facilities, because what we found in one sample, this is the raw sludge. I mean, after the treatment of thickening, dewatering, drying, it is impossible to monitor the active virus in sludge. But we have to be careful. We have to be on safe side. Do not use the sludge for land application during this pandemic period. Second advice is for the academic people, because as I'm an also academic person, and I'm performing some researches under the lab conditions. And as you well know, we are using the real wastewater for the treatment studies under lab conditions. We are using the sludges for the start of the new reactors. As a part of this surveillance study, I'm not advising to use any raw sludge, any wastewater under lab conditions during this pandemic period. And the second advice for the treatment plant operators, even the World Health Organization, EPA, publishing many documents for the protections that has to be taken into account in treatment plants. But I would like to repeat once more. For the treatment plant operators, they have to use the protective masks, wearings, masks, gloves under treatment plant conditions, and especially for the workers of around aeration tanks, which we are using the diffuse aeration systems commonly in Turkey. The mist generating from the diffuse aeration, the plant workers have to be really careful, and they have to use the additional masks and protective maybe the face shields, gloves, etc. Those are the advices to protect ourselves although the risk is really low, in my opinion, as a scientist, we have to be careful and we have to take the necessary precautions. Thank you.
Thank you. Dr. Chandran, we would like to hear your comments as well, please.
Yes, thank you. I think we are focusing more on the aqueous phase, and that's acceptable because we are, after all, looking at wastewater treatment and an alignment of microbial related safety aspects as it relates to wastewater treatment. There is more and more evidence that aerosolization and transmission of SARS-CoV-2 through aerosols is an important mode of transmission. This aspect might be the interest of some activities which are underway within the context of wastewater treatment. But I do want to point out, since I do point this out because there have been more and more questions coming out in this direction, at least within even the last week or so. Yes, aerosol-based transmission of SARS-CoV-2 in general. Again, you know, this is the importance of general versus very specific contexts. In general, aerosol-based transmission is very important and has been shown to be important. But again, in the context of wastewater treatment, it is unclear as of now the degree to which infective virus is coming into a plant and then getting aerosolized. So again, I think it's the nuances that we should focus on. But I think this is an important gap that might be interesting to consider as well. The infectivity of the viruses in all three phases now: liquid, solids, and the aerosol phase, and then the potential for transmission through the aerosol phase. This is one of many questions that probably are floating around right now. I figured I'd flag this because this was not raised already.
Thank you so much. Mr. Bhagwan, is there any reported case through wastewater spread in your country? Can you unmute yourself, please?
So we haven't yet got any results. Like I said, it's one of the studies that we are in parallel busy with, okay? And, they are going through the experiments and those kind of stuff. So I don't have any results as yet, but like what Professor Karthik has mentioned, that we're working on the assumption, that to date, no live viruses have been found, in the influence stream. So the probabilities of aerosol activities on the treatment plant being infectious is, not a big concern yet, but it's not something that we should not confirm, okay? So hence, we are looking at, that aspect, but we've put the precaution out to all wastewater treatment plant operators to go into a PPE mode, okay? Just to create that barrier, because of we haven't confirmed it as yet. So hopefully through the study we're busy with, and there's several other studies globally that are also looking at this aspect, we'll be able to confirm whether it's a concern or not.
Okay, thank you so much. So although the emphasis of this webinar is on wastewater surveillance, we know that particularly in some countries, the community is curious if it's safe to use tap water during the pandemic. Dr. Saatchi, as an expert on drinking water treatment, we would like to hear your comments as well, please.
Whether the virus can go into drinking water, there are two ways. One is, of course, we have said that the virus is shed by aerosols and by the stool of the patients. And the fecal material goes into the wastewater, as we have discussed. And at even, temperatures like 20 to 25, we cannot even detect the virus. But there are cases we have detected them in the wastewater treatment plants. Just one case, it was a viral virus. So the wastewater, assuming it carries the virus and assuming it is alive, which is a low probability, it should get into drinking water pipes by infiltration. And usually the water pipes are kept under pressure. But in some countries, they are not always under pressure. You give water to one region and then you drop the pressures to another region, and there may be infiltration into drinking water pipes. But there we have the residual chlorines. We chlorinate the water, especially in countries like ours. The residual chlorines, they are enough to kill the more hardy viruses we talked about, like rotavirus, hepatitis A, etc. So this virus is very fragile compared to these viruses. So I don't see any way it can go through the water treatment plant and to the people or directly to the homes of the people. It will be inactive even if it happens. Now, if you have wastewater discharging into drinking water reservoirs, which is a possibility, of course, there are long waiting times in the big reservoirs. We are talking about millions of cubic meters under sunshine. We have some disinfection taking place over there. Then the next phase is the water treatment part. Water treatment, like simple coagulation, flocculation, and filtration removes even the cryptosporidium, very hard to kill. You cannot kill cryptosporidium by chlorination very easily. But even coagulation, flocculation, it takes like 2 logs of it. Like 100 enter one and one goes up. When we have chlorination, we always have chlorination at the very end. And we have, of course, sand filtration. I don't believe it will ever pass through the water treatment plant. So therefore, I don't see it as a danger in that sense. Mostly it passes through aerosols. And in the wastewater treatment plants, we have to be careful with the surface aerators, which they generate lots of aerosols. There I think the operators should be careful. With diffuse aeration, like 5 meters at the deep depth of 5 meters, we don't have much aerosols in the system. Thank you.
Thank you all. And now I would like to hear your opinions of our panelists about how the general framework should be for a nationwide SARS-CoV-2 surveillance study. Dr. Kocamemi, please.
Okay, I explained the logistics in Turkey during my talk. Unfortunately, while we are starting our surveillance study in Turkey, we don't have time. The pandemic started and we urgently started the surveillance study. So we learned the logistics while the project is going on. And we gained great experience during the project. But certainly, if there was no the help and support of our stakeholders, this project would be impossible. And here I would like to thank all our stakeholders, municipalities, treatment plant operators, lab virologists, drivers, and all other people who worked in this project. But we learned many things from the study, and in my opinion, if you are planning to conduct such a surveillance study, first of all, you have to somehow provide the governmental support. Without the governmental support, you can never perform such a wide surveillance study in a country. A financial budget is a must. Without money, you cannot do anything. And as we mentioned, those tests are really expensive. Those molecular tests are really expensive, and we need labs. At least biosecurity level 2 labs are necessary for those studies. 3 are necessary for activity tests. And for the countries like Turkey, and maybe it is the case for South Africa as well, but not the case in USA, Kartik, we need time for the importing of the consumables to the country. We are waiting 10, for example, I can give an example for this week. Our Istanbul lab is waiting for the 0.45 micron filters for 10 weeks. It is incredible. I mean, the availability of the consumables are really important, but most importantly, in my opinion, is the cooperation between stakeholders. The stakeholders have to collaborate, cooperate, and this is the most important part of this surveillance study. And I think we did this in Turkey. We are very lucky. We work together with municipalities, state water works, virologists in veterinary labs, and treatment plant operators, workers together efficiently. This was, I think, the major necessity of the success of a surveillance study. Thank you.
Thank you. Mr. Bhagwan, we would like to hear your thoughts, please. Can you give us brief information about the framework in South Africa?
So you know, we at the proof of concept with a design of what we want to see in terms of incrementally scaling up the initiative. Okay, and I think Bilge has already touched on it. Without the political will and the finance, of course, you know, it's not possible. You know, that's the first thing. At the moment, I think that one of the important aspects is that we did not want to deflect any attention to individual testing, because if we came in and said wastewater surveillance can solve the problem, I'm sure that politically people would have stopped doing the individual testing, and then they would have blamed you around it. What we're saying is that this is complementary, okay, and it's a low-cost method to help you to go to the hotspots areas rather than sweeping, okay, the population, etc. And that's more cost effective. Okay, so where we are at the moment is that we have a framework around incrementally moving up, but it's trying to build the partnerships between local government, national government, as well as the network of laboratories and partners in the process. Especially when you have to get to 896 treatment plants and 296 municipalities. You know, we're using all the power of the political will and sometimes even the legislation, okay, because it's giving us greater opportunity in the time of this crisis under the disaster management frameworks to institute regulation to make things happen. You know, so one of the regulations we're looking at is relaxing the laboratory requirements to level 1, or you know, I mean the normal wastewater laboratories in municipalities. So we can do much of it. So these are all the elements we are building as we are going along. And like I said, that we believe we're in the deep end, and that helps us to move fast, you know, to the shallow end, that we can get this moving. Maybe in 2 months' time, if you ask me how it is working, I'll be able to give you an answer. But you know, there's great interest now. In fact, next month or the next few weeks, we're having a ministerial launch of the program to give impetus that we can now scale it up and give more attention to it. And I think the proof of case studies and the results is bringing the attention we want, you know, in terms of accelerating what we do. Thank you.
Thank you so much. Dr. Chandran, US is a huge country, and I guess it would be a nice example for countries governed by the state system. What do you think about the practices in the US in this context?
Yeah, currently there are many municipalities in the US which are engaged and involved and part of monitoring studies. There are many of these. There are some municipalities which are themselves leading this effort, which is very good to see. So they are leading this effort from inside, and there are some promising results that have been already published. One recent example is that of the Hampton Roads Sanitation District, where this is an internal study that is being led by HRSD scientists, and they've come out with some very nice data and results. There are other municipalities which are collaborating with research groups. So we are working with quite a few municipalities. There is actually now a discussion of a national scale surveillance study. It's under discussion. This is from the CDC, which is under discussion. This has been going on for quite some time now, and essentially there are so many questions that need to be considered. There are so many aspects that need to be considered. Do we look at just utilized systems? Do we look at 20% of the US wastewater flow is treated by septic systems, which is quite substantial, 20%. So then we need to look at those as well. When we are looking at wastewater streams, it's not enough to just look at households, industrial, domestic sewage streams. We need to zero in on facilities like hospitals, like incarceration facilities, which have also been pointed to be hotspots of COVID infection. So all of this is being discussed. I know there might be some back and forth in terms of standardizing approaches, but when we are talking about national scale, when we are talking about a national scale effort, surveillance and predictability is just one of the aspects, and maybe it's not important at all. When we are talking scale, this is when actually standardization has to be done. This has to be done. There is just no way around it. Otherwise, we'll be comparing. There will be no basis for comparison. And so, under some circumstances, standardization is absolutely important. And so that is also under discussion right now. So in the US, it's a bit more distributed. People are participating in their different capacities, but now there is actually discussion of a national effort going on.
Okay, thank you so much. Dr. Saatchi, how do you think decision makers should contribute to the nationwide surveillance studies? In your opinion, what is the responsibility of decision makers?
They have lots of responsibility. I mean, the way we could make this research is, of course, by political will, by the decision of the Ministry of Forestry and Agriculture, because to sample from 81 districts of Turkey is not something a university can do. So we use the facilities of State Hydraulic Works, DSI, and they have compounds almost all locations of Turkey. and they helped us to transport the samples, to take samples, etc., in cold chain. And the second thing we use is we use the laboratories of the ministry. They have the adequate laboratories for this. But you know, doing this research, collecting samples and analyzing is one part. The other part is to apply it. And there you need political will as well. You have to take permissions to take wastewater samples. And it again needs, you know, there is lots of bureaucracy involved, and it needs political will again. Maybe, you know, they can be more persuaded using, when taking samples from, as I have said in my speech, locations of interest. For example, we are a tourist country. We have lots of tourists coming, and they come to big touristic complexes where they have one sewer line going out or two sewer lines going out. And if you sample from this at the very exit, you can tell whether you have a case there or you have many cases there. So the systems we are using can locate one, say you have one COVID case in 100 people. This you can detect very nicely. Theoretically, you can detect 1 in 2 million people, which is, I don't think, very, you know, possible. But at least you can tell whether they are increasing, decreasing. Suppose you measure this on the airplane, you know, and they take the names of the passengers on the airplane. And if you can get the stool samples after the flights, especially long trips, you can tell there was a case there or not. That's, so political will is everywhere to get permissions, to pay money for this. So it's, as I have said, you need 2 legs for this. Maybe you need 4 legs, you know, much better that way, more stable. Thank you.
Esra, can I add something to here? Because there are some questions in the QA box to us. And they are asking, is there any correlation between wastewater analysis and the case numbers? I think this is also related with this question. I think in order to find such a correlation, first of all, the ministries, different ministries of government have to collaborate with us. And in Turkey, we have some difficulty to obtain the case numbers in order to correlate our data with the number of the cases. And I think this is the case in South Africa as well. I think Jay, you said something like this. Huh? So for the while we are considering the logistics, we have to also consider also this. The different ministries have to cooperate for the development of an early warning system, for the development of a methodology based on the wastewater surveillance.
But there was, go ahead, please. Go ahead.
Yeah, so what's emerging in this space is the issue of ethics in sharing and publishing data, especially if you're linking it to individual clinical cases, etc., and communities. So it's a new discourse that has just come up. And that's why aligning whatever we do to the national health system that has the mandate under the Disaster Management Act to report and bring out the correlations and the trends is very, very important. Otherwise, individually, you're going to be stuck with the ethics issue, okay, in terms of publishing and sharing the outcomes. So that's just an early development that we're starting to see emerging. Sorry, Doctor.
There was one other question. I think Bilge answered that about using wastewater in irrigation and using sprinklers. But of course, you have to take precautions and you have to chlorinate the water. You know, you should be careful about the aerosols. Although our research shows it's not alive, but you should disinfect the water which is used for irrigation. That's a side answer.
Thank you. Finally, before closing the webinar, I would like to learn if it's indeed possible to develop an early warning system with wastewater surveillance studies. Very briefly, can we listen to you, Dr. Alparslan Kocamemi, please? Can you unmute yourself, please?
Okay. I mentioned during my talk, at the beginning of this project, I was telling that we are trying to develop an early warning system based on the qPCR measurement of wastewater samples. And we know that it is impossible now. It is impossible because logistically it is impossible. Because of the duration of the test, because of the lab capacities, manpower, availability of the consumables, we talk about all of them. So in my opinion, we have to divide the early warning into two parts. In the first part, in the short term, as scientists, we have to focus on the virus concentration method. We have to develop a quicker and cheaper virus concentration method somehow. The second is the long-term early warning. We have to focus on the biosensors, and to do this, the scientists from the different disciplines have to work together. Electrical engineers, electronic engineers, molecular biologists, environmental engineers, they have to work together to develop a biosensor specific to not only to SARS-CoV-2, but also for the other viruses. We have to focus on the development of the biosensor technology. Thank you.
Thank you. Dr. Chandler, we would like to hear your opinions, please.
Yeah, I agree with Bilge in terms of the needs. I would also like to add another need. It's also important for us to figure out where to sample, whether sampling at the influent of centralized wastewater treatment is the only option or the best option, or whether there are other points along the water and sanitation flow where sampling can be instituted. I don't have the answers. I'm not really sure we have the answers collectively, but it might be good to take a look maybe upstream as well.
Okay, thank you. Mr. Bhagwan, please.
Yeah, so you know, I'm very optimistic, and I want to share it into two categories. There's the dashboard, okay? The dashboard is about hotspots, trends, early warning. That is possible with what we are generating. Otherwise, you know, we shouldn't continue. I mean, so I'm quite optimistic we will solve that part. The second part is the intelligence part of it, you know, and that's the quantification and the prediction. And all the stuff that goes with what happens with the temperature, what happens with the dilution, you know, what's the influence of this character on the wastewater stream, on the RNA signal. So there's a whole lot of data analytics and intelligence that we have to build on. And that's more longer term. But I think if we get the approximation right in terms of the hotspots, the trends, the early warning, it gives us the platform to leap into, you know, the quantification and prediction through the analytics and the intelligence as we improve the science around what we are doing. And I think the way we're going about it, the kind of innovations and the tools that we're developing, I don't see us being very far away from offering this as a longer term solution.
Okay, thank you. Dr. Sachi, we would like to hear your comments as our last speaker, please.
Yes, I'm optimistic as well. I mean, this method is not a new method. It has been used for narcotic reasons. It was used for polio detections. And we are learning more about it. And I think Dr. Kartik's, Professor Kartik's, you know, thinking about where we should sample is also very important, because we sat comfortably at the inlet of the treatment plants and we started sampling, and everything was going very well because we have a wide range of area where the treatment plant serves. Now, in the last month, we started getting, you know, negative results. Then we thought maybe our PEG is, you know, out of date. No, it was not. We checked our results again and again and again. We all get negative results. We know there are cases in the area. So we think it's temperature. So if the mountain doesn't come to you, you go to the mountain. And we have to go to the place where the cases happen. That's why I said we have to have locations of interest. I really want to see this applied to touristic places. You know, we have one Airbus of Russians coming to Antalya, sitting in one hotel complex. I would like to measure, you know, whether they have a case or not, whether they developed the case during the days they. So it can be practical if you go to the source. And of course, again, it has to be, you know, we need political will. We need people. I think we have to have webinars just for decision makers.
Right.
Just to show them.
Thank you. So before closing our webinar, I would like to thank our panelists for joining us today. We are grateful for sharing their idea, their data, findings, and experiences explicitly. Despite the many drawbacks, I believe a positive output has evolved with this pandemic. We have witnessed an incredible amount of collaboration, cooperation among people from academia, industry, utilities, government, and non-government organizations. And I hope this webinar has enriched this achievement in the world. Thanks to our attendees for their valuable time. And last, I would like to give my special thanks to Dr. Alparslan Kocamemi, because today it's her birthday and she has shared her value. So
Okay.
have a good day. Thank you.
Happy birthday.
Happy birthday.
Thank you.
Thank you.
I think you have an agreement with Zoom.
Okay.
Yes, okay. I canceled the first webinar for that reason. You are right.
You told them to cancel it the last time, so
Yes, yes.
coincides with your birthday.
Okay.
Thank you, everyone.
Thank you. Bye-bye.